Hello everyone. Now we'll discuss about an important property from discrete Fourier transform, which is circular shift of a sequence. Now we have shift in two different ways, one in time domain and one in frequency domain. So in first case we'll discuss about how circular shift can occur in time domain, and then we'll switch to frequency domain. Now in order to understand circular shift, that means definitely we should have to draw a circle and some shifting process has to be carried out. So prior to that, let us assume that we have a signal or a sequence which is non-periodic or aperiodic in nature. So I'm writing it here. Let's suppose we have a sequence which is given as x of n. Now here this is non-periodic, so let's suppose it has a value for let's suppose 0, 1, 2 and for 3. That means it is in existence for 4 samples simultaneously 0 to 3 with the amplitudes as 1, 2, 3 and 4. Here the integer is n. Now if you observe this sequence, it is definitely non-periodic because it is not repeating after 4 samples. Now in order to make this particular sequence periodic in nature, if I add n number of samples to the right or to the left with equal amplitudes, maybe the possibility is signal will be periodic in nature. How it is periodic in nature? Let's suppose here actually we have 4 samples, so I'm adding 4 samples as well as subtracting 4 samples. So when I add 4 samples to this particular function, how it will be changed? So here we'll draw this term as it is. Now when I add 4 with 0, 0 plus 4 will be 4. That means this function will be shifted to the right side by 4 units. So here we'll get 4, amplitude will be 1. Now 1 plus 4, 5, amplitude will be 2. Next 2 plus 4, 6, amplitude will be 3. Similarly, that in the last case 3 plus 4, 7, amplitude will be 4. Correct. Similarly, when you subtract 4 from this particular term, what will happen? This is 4 minus 3, 1, 2 and so on. That means, see, the signal is shifted to the right side. Now when we subtract from this, again we'll get some terms shifted to the left side. So the possibility will be we'll get the terms like, again for 0 we'll get amplitude 1, for 1 amplitude is 2, for 2 the amplitude is 3, and for 4 the amplitude, for 3 the amplitude is 4. Similarly, when we subtract it, maybe the possibility is going to be in a similar way. How it can be possible? So for minus 1 we'll change the color pen, so we'll get after 0 it will be minus 1. So for minus 1 the amplitude will be 4, for minus 2 the amplitude is 3, then it is minus 3, amplitude 2, and this is minus 4, amplitude is 1. How it is possible, sir? You can see it here: 0 minus 4 minus 4, 1 minus 4 minus 3, 2 minus 4 minus 2, and 3 minus 4 will be minus 1. So your signal is shifted to the right as well as to the left side. Now it seems to be periodic signal. Why? Because it is repeating after 4 samples. You can check it here. After 0 the amplitude is 1, after 4 the amplitude is 1, and it seems to be possible for every combination. So now this is our periodic function. So let's suppose this is written as xp of n, which stands for periodic function. Now if it is periodic function, it is simply showing that it is repeating itself. That means it is shifting to the right as well as to the left. How we can fetch these values? So for that case, let's suppose I am shifting the periodic function by 2 units or simply by 1 unit. So if I write the first term as xp of n minus 1, that means we have to add 1 to the given function. So when we add 1 to the given function, it will be shifted to the left side, sorry, right side. So definitely we can get, see, when I add 4 with 1, minus 4 with 1, we'll get minus 3, then we'll get minus 2, minus 1, then we'll get 0, 1, 2, 3, 4. Again 0 plus 1 1, so it will start with 1, then it will be 2, then it will be 3, then 4 plus 1, sorry, 3 plus 1 will be 4, so we'll get, and so on up to 7 plus 1 as 8. Similarly, when I shift it by 2 units, minus 4 plus 2 will be minus 2. That means it will be shifting towards the right side. So it is simply indicating that depending upon how many samples we are adding or we are shifting. Now I will take only 4 required samples, that is 0 1 2 3. So when we take 0 1 2 3 from this particular term, so for 0 we have the amplitude as 4, for 1 amplitude is 1, for 2 the amplitude is 2, and for 3 amplitude is 3. This is our term shifted by 1 unit. Similarly, when you shift it by 2, 3, 4 units, we will get the sequence to be repetitive. Now we'll represent this on a circle. So let us try this with the help of circle. So we'll keep this for the reference, and we'll try to fetch the terms over here only. So here I'm drawing the first circle, though it is doesn't looks to be a circle, assuming that this is a circle, and I'm plotting the terms 0 1 2 3. This is for x0, x1, x2 and x3 with the amplitudes from this term 1 2, so 3, and this is going to be 4. Now they are at the mean position, at the center terms. Now when the sequence was shifted by 1 unit to the right, we got these particular values. Now let us plot these values. So I am writing, simply drawing the second circle. My drawing is not perfect, so you can understand this one. Now here x0 value is 4, so we'll get 4 here. X1 value is 1, so we'll get 1, then it is 2, and this is 3. Now compare these two circles. You can see it here. Initially the value of 1 was here, and in this case it is here. That means it is shifted by 1 unit circularly. Similarly 2 now is here, 3 now here, and 4 was here, it is here. Similarly, when you shift it by 2 units, this one will go here, 2 3 4 will be here. When we shift it by 3 units, definitely 1 will be here and 4 will be here. And when we shift it by 3 units, we will get the same sequence. That means when we complete it by 4 samples, we will get the original function. Okay, let's try this. This shifted by 1 unit. When we shift it by another time, maybe the possibility will be, it will be 1, this is 2, this is 3, this is 4. When I shift it by second unit. Similarly, when we shift it by another time, we will get the 4 terms, maybe like this, 1 2 3 4. And when you shift it by one more time, we will get the positions as 1 2 3 4. So after 4 samples, we are getting the same function, and this term is called as circular shift of a sequence. That means every sequence which is periodic in nature can be represented in terms of circular shift of a sequence. Now what we obtain from here, when we add the given sequence with n number of samples, it shows the repeaticity, and this is the base of circular shift of a sequence. Now this can be written as circular shift of a sequence is written as x dash of n is equal to x of n minus k to the base n, where we can simply call this as index modulo n or modulo n. That means with the given sequence we can add n number of samples, or we can subtract n number of samples, or simply we can write this term as x of n minus n also. No issue with that one when we have only the x of n as term. This is the important property as far as discrete Fourier transform is considered. Now let us see the proof. This was only the base. We'll go for the proof. So here the statement is there. If x of n is a sequence whose DFT is x of k, then x of n minus m to the base m or module n DFT will be this term. Now in order to find, or in order to prove this property, let's try with the proof as finding DFT of this sequence. I'm writing directly DFT of this particular sequence can be written as 0 to n minus 1. This term will keep as it is, into e raised to minus j2 pi k n by n. I hope you understood the basics of circular shift of a sequence. Now we'll go for the proof. Now we'll simply try to again simplify the terms quite in a comfortable way. For that case, if I observe this variable as m is here, so I can shift, or let's simplify this. I'm writing the term as n0 to first summation. I'm writing m minus 1 because we have the variable as m. Again the term are going to be same, x of n minus m base n with the exponential term as it is, plus next summation term. Now its end is m minus 1, so it should start with m and our upper limit is n minus 1. What it indicates? Base is 0, upper limit is n minus 1. We are just simply splitting it, and this term as it is, x and our exponential term, which will keep in a same manner. Maybe in the background you are getting the noise of noise or pleasant sound of rain. It is heavily raining in our region, so just enjoy that segment also. Now instead of this term, as usual, we'll add the sequences, which I can write now. I can add n number of samples, so this becomes n plus small n minus m exponential as it is, plus this one m to n minus 1, again x of n small n m and exponential term as it is. Now we'll try to solve this summation first, and then we'll switch to the second one, so that it becomes quite easy to understand in a proper way. So here, when I concentrate for this particular sequence, we'll solve only this one, summation 0 to n minus 1 into exponential, that will not be changed at all. Now, as you know, we want a single variable, so I can substitute this one with another term. Let this term is equal to L. So we have two limits. When I put n0, I'm writing it here, for n is equal to 0, L becomes equals to n minus 1, and for n is equal to n minus 1, when I put it here, this is n plus n minus 1 minus m, so minus m. In this way, there is a correction. Here we are just put n1, mm will get cancelled, and we are getting this term as n minus 1. Simply just make that particular correction over here. So